Welcome to Centennial Academy. Today we're going to take a look at stoichiometry. Stoichiometry is a quantitative approach to determine the amount either required or will form in a chemical reaction. There are three types of stoichiometry. First one is gravimetric stoich. Second one is solution stoich. And third one is gas stoich. Today we're going to look at gravimetric stoichiometry. Grav stoich is made to determine the mass or moles for the required substance that are formed in a chemical reaction. This involves mass-to-mass calculations, mass to moles, as well as moles to mass calculations. Before doing any questions, we're going to walk through the steps on how to do them. First, write the balanced equation. Second, list the given info under the appropriate elements. Third, identify the types of the question. And fourth, convert into moles. Fifth, use molar ratio to balance out the question. And sixth, convert into desired units. Let's take a look at some example questions. Nitrogen in the cylinder of a car reacts with oxygen to produce nitrogen monoxide. How many moles of nitrogen monoxide are produced from the combustion of 1.52 moles of nitrogen? First, we got to write the balanced equation. Nitrogen gas, remember always to write your state, plus oxygen gas forms nitrogen monoxide gas. Secondly, balance out the equation. In this case, it will be 2 nitrogen monoxide. And list out the given, which is 1.52 moles of nitrogen. And I want you to determine how many moles there are for nitrogen monoxide. In this case, we would determine it is a moles to moles question. First, we always write down by what we have, which is 1.52 moles of nitrogen gas, multiplied by, remember, whatever you want to get rid of goes in the bottom. Therefore, it will multiply by 2 moles of nitrogen monoxide with 1 mole of nitrogen gas, because there's 1 right here and there's 2 right there. This will give us 3.04 moles of nitrogen monoxide. And remember, always have your answer in significant digits. Let's look at another type of question. Given 0.25 grams of zinc reacting with excess hydrochloric acid, determine the amount in moles of acid required. First, again, we write out the balanced chemical equations. Zinc, solid, plus HCl, aqueous, reacts and turns into zinc chloride and hydrogen gas. In this case, we will balance the questions first, and then we will write out what's given. We have 0.25 grams of zinc, and we need to determine how many moles there are for hydrogen chloride. In this case, it's clearly a mass to moles question. Therefore, we list out what we have so far. 0.25 grams of zinc multiplied by 1 over the molar mass of zinc because of the molar equation. In this case, multiply to determine the amount of mole there are, which is 2 moles of HCl and 1 mole of zinc, because when you try to get rid of zinc, it goes to the bottom. It will equal to 0.00764 moles of HCl. In sig digs, it will turn into 7.6 times 10 to the negative 3 moles of HCl. This is the part B of that question. How many grams of hydrogen gas will be formed after the reaction is complete? We have the balanced equation written out right here, except this time we're trying to find the mass of hydrogen gas. In this case, it will be a mass-to-mass question. Therefore, we will write 0.25 grams of zinc multiplied by 1 mole over the molar mass of zinc, and then we will balance out the molar ratio, which is 1 to 1 molar ratio, multiplied by the molar mass for hydrogen divided by 1 mole of hydrogen. This will give us 0.0077 grams of H2, turns out to be 7.7 times 10 to the negative 3 grams of hydrogen.
Alright, question number 4. Given the following reaction, answer part A and B. So the reaction is as follows. NaClO3 produces NaCl and oxygen. So part A asks us 12 moles of sodium carbonate will produce how many grams of oxygen? As you can see, you always want to balance your equation first. Afterwards, you always state what's given to you and what you're trying to find. And when it comes to calculations, you always start with what's given, which is 12 moles of sodium carbonate. You use the molar ratio to get the moles of oxygen. And then you multiply the molar ratio, or you multiply the moles of oxygen by the molar mass of oxygen, which is 32 grams. And that will give you 576 grams of oxygen, or with proper sig digs, 5.7 times 10 to the 2 grams of oxygen gas. Part B asks us how many grams of NaCl are produced when 80 grams of oxygen are produced. As you can see again, we have the balanced equation given. And in this, you have 80 grams of oxygen given, and you're trying to find the grams of NaCl. So when it comes to your calculations, you always start with what's given, which is 80 grams of oxygen. You divide it by its molar mass, which will give you the moles of oxygen. And afterwards, you do the molar ratio to get the moles of NaCl. And from here on, you take the molar mass of NaCl and times it by the moles, and you should get 97.417 grams, or converting it to sig digs, which should be 97 grams of NaCl. Alright, next question. Determine the mass of precipitate produced when 3.5 grams of lead-2 nitrate in solution reacts with a solution of ammonium iodide. As always, you want to write your balanced chemical equation first. Afterwards, you want to state what's given to you and what you're trying to find. In this question, it asks to determine the mass of the precipitate produced. So out of the two products, you will have to find which one will be the one that will precipitate. And by looking at the solubility chart, you can determine that it's PbI2. Afterwards, you use unit analysis in which you state what's given to you, and you use the molar mass of PbNO3 to find the moles of PbNO3. Then you do the molar ratio to find the moles of PbI2, and then you times it by the molar mass of PbI2 to get the mass, which should be 4.9 grams to the correct sig digs.
Thank you for watching.